Hello and welcome to the last video for the chapter number systems. In this video we are going to look at how to find the square root of a number geometrically. There is a small construction involved. So first draw a line AB with length equal to x, where x is the real number for which you want to find the square root. So if you want to find the square root of a number like 3.5, so x is 3.5 in this case. So draw AB with length equal to 3.5. Then extend B to C, and BC should have a length of 1 unit. So you have AB of length x units and BC of length 1 unit. And then draw a circle with AC as diameter. So draw a circle with AC as diameter. So you don't have to draw a full circle, you just need a semicircle, as you can see in the figure. And from point B, draw a perpendicular which meets a circle at D. So this line BD is perpendicular to the diameter and it meets the circle at the point D. Now the length BD will be equal to root of x. So this length BD will be equal to root x, and if you transfer BD to a horizontal number line, you can plot root x on the number line. So we'll see that number line part in a bit. But before that, let's see how this construction works. Let's try to prove that BD is equal to root x. For that you need to consider this triangle OBD. So in triangle OBD, you have this angle B as a right angle. So you can apply Pythagoras theorem. You can write OD squared is equal to OB squared plus BD squared, or BD squared equals OD squared minus OB squared. Now what is the length OD? You know that OD, this OD here is the radius of the circle. The diameter of the circle is AC. So you know that AC is the diameter, and AC equals x plus 1. So if you just look at the figure, it's clear that AC equals x plus 1. So you can write OD equals half of AC, because OD is the radius and AC is the diameter. So OD is AC by 2 or x plus 1 by 2. So you can put that value of OD in this equation. So this is x plus 1 by 2 whole squared. Now you need to find OB. You can write OB as OC minus BC. So if you just look at this part of the figure here, OC minus BC will be equal to OB. And you know that OC is the radius. So OC is the same as OD, which is equal to x plus 1 by 2. So that's OC, and BC is 1. So if you do this calculation, you will get x minus 1 by 2. So OB is x minus 1 by 2. Now if you simplify this, you will get 4x divided by 4, which is equal to x. So you can write BD is equal to root of x, and that's how you prove that this length BD is equal to root x. Now let's see how to actually plot root x on the number line. So this semicircle here is just copied from the previous figure, and the only difference here is that the point B, so this point B is 0 of the number line. So you have this horizontal line here, BCE. This is our number line, and point B is the number 0. So since BC is equal to 1, so you can see here BC is equal to 1, this point is the number 1. So finally, after you do the constructions, you get BD is equal to root x, and with center B and radius BD, you just need to draw this arc here. So this, you just need to draw this arc so that you get the point E, and BE will be equal to root x. So that's how you plot the point root x on the number line for any real number x. Now let's move on to the simplification of irrational expressions. So here you just need to use the old familiar formulae. So let me just write down a few formulas that you'll need to use. Let's work out a couple of problems to see how you can simplify irrational expressions. So the first problem, 5 plus root 7 into 2 plus root 5. You need to simplify this. So here you just need to write 5 into 2 plus root 5, just as you do it for rational expressions, plus root 7 into 2 plus root 5. This is just multiply 5 into 2 is 10, and 5 into root 5 is 5 root 5, plus 2 root 7 plus root of 35, or root of 7 into 5. You use this formula. So you cannot simplify this any further. So this is your final answer. Let's do one more problem. 5 plus root 5 into 5 minus root 5. So you can identify that this is of the form a plus b into a minus b. So you can write this as 5 squared minus root 5 squared. using the formula for a plus b into a minus b. So this is 25 minus 5, which is 20. So that's how we simplify irrational expressions. Another common set of problems will be to rationalize the denominator. So for example, if you have a question like rationalize the denominator of 1 by root 2, this one. So by rationalize the denominator, we mean that the denominator should be converted to a rational number. So in 1 by root 2, you know that the denominator is an irrational number, root 2. So to convert this to a rational number, you multiply the numerator and denominator by root 2. So here you will get root 2 divided by 2. So that's the answer. So if you have just some root x in the denominator, you need to multiply both sides by that root x. So if it is 5 by root 2, for example, you just need to multiply both sides by root 2. That's how you rationalize the denominator. Now let's consider another example, 1 by 2 plus root 3. So if you are asked to rationalize the denominator, here you have to multiply both sides by 2 minus root 3. If you multiply both sides by 2 minus root 3, you'll get 2 minus root 3 divided by 2 plus root 3 into 2 minus root 3. So this is of the form a plus b into a minus b. So it's a squared minus b squared, or 2 squared minus root 3 squared. And that simplifies to 2 minus root 3 divided by 4 minus 3, which is 1. So that's just 2 minus root 3. Let's just take a look at this last example. To rationalize the denominator here, you have to multiply both sides by root 3 plus root 5. And the rest of it is very similar to the previous question. Okay, so this is the final topic for this chapter, law of exponents for real numbers. In smaller classes, you have seen laws of exponents. So a raised to m into a raised to n is equal to a raised to m plus n, and a raised to m divided by a raised to n is equal to a raised to m minus n. A raised to m whole raised to n is a raised to m into n, and a raised to m into b raised to m is ab whole raised to m. So these are the 4 laws that you must have studied in smaller classes. So the thing to note here is that in earlier classes, when you studied these laws, you assume that a, m and n are natural numbers. Now the only difference is that you can use these same laws, and there's no restriction that a, m and n should be natural numbers. So a can be any real number which is greater than 0. So a is a positive real number, and m and n are rational numbers. So instead of seeing just exponents like 2 raised to 3 or 6 raised to 5, now you'll also see exponents like root 2 raised to 3 by 2, for example. So the base can be any positive real number, and the exponent can be any rational number. So that's the only difference. The laws themselves don't change. Let's work out a few example problems for laws of exponents. So if you want to compute 2 raised to 2 by 3 into 2 raised to 1 by 3. So here you need to use this formula, a raised to m into a raised to n is a raised to m plus n. So here it's 2 raised to m plus n will give you 2 by 3 plus 1 by 3, which is 2 raised to 1. So the answer is 2. Let's look at another example. If you want to compute 3 raised to 1 by 5 whole raised to 4. So this is of the form a raised to m whole raised to n, and you know that this is equal to a raised to mn. So here you just need to multiply 3 raised to 1 by 5 into 4, which is 3 raised to 4 by 5. Before we end this chapter, we just need to understand the meaning of having rational numbers as exponents. For example, if you have a number like 4 raised to 3 by 2, this can be computed in 2 ways. So this is either 4 raised to 1 by 2 whole cubed, or it can also be written as 4 raised to 3 whole raised to 1 by 2. So these are 2 ways of writing the same exponent, and this can be simplified as 4 raised to 1 by 2 is nothing but root 4. So root 4 whole raised to 3. So root 4 is 2. So 2 cubed is 8. So that's one way of doing it. Or it can be written as 4 cubed whole raised to 1 by 2, or 4 cubed is 64 whole raised to 1 by 2. So that's root 64, which is 8 again. So you just need to note here that a raised to 1 by 2 is the same as root a raised to 1 by 3 is the same as cube root of a, and so on. So that's the end of the chapter. Thanks a lot for watching.